This is the solution for question 2 of homework 8. So we are given a Poisson process n with parameter lambda, and we are given a random process x of t which is equal to 1 if n is odd in 0 to t and minus 1 if n is even in 0 to t. So first we are asked the probability of x of t equal to 1. So x of t is equal to 1 if n is odd in 0 to t. So n can be 1, 3, 5, 7, so on up to infinity. So any odd number. So let's find the probability of x of t equal to 1. So probability of x of t equal to 1 is probability of n in 0 to t equal to 1 and n in 0 to t equal to 3, so on up to infinity. So substituting k equal to 1 for this, k equal to 3 and so on in the given formula. So here t1 and t2 are 0 to t, therefore t1 is 0 and t2 equal to t. Substituting them, we get e power minus lambda times lambda t by 1 factorial plus e power minus lambda t into lambda t whole power 3 by 3 factorial plus so on up to infinity. We take e power minus lambda t common, we get this series. So we have to find the value of this series. Let's check the definition of e power lambda t. So the expansion for e power lambda t is 1 plus lambda t by 1 factorial plus lambda t whole square by 2 factorial plus so on up to infinity. And e power minus lambda t expansion is 1 minus lambda t by 1 factorial plus lambda t whole square by 2 factorial minus lambda t whole cube by 3 factorial plus so on. So all the even power terms have plus and the odd terms have minus. So if we subtract the e power minus lambda t from e power lambda t, we get the required, and divide by 2, then we get the required series. So therefore e power lambda t minus e power minus lambda t by 2 equal to the required series lambda t by 1 factorial plus lambda t whole cube by 3 factorial plus so on. So we substitute this in place of the expansion, we get e power minus lambda t times e power lambda t minus e power minus lambda t by 2. Multiplying it, we get 1 minus e power minus 2 lambda t by 2. So this is the probability that x of t equal to 1. But x of t has only two possible values, which is 1 and minus 1. Therefore the sum of these probabilities must be equal to 1. Therefore probability of x of t equal to minus 1 equal to 1 minus probability of x of t equal to 1. Therefore 1 minus 1 by 2 times 1 minus e power minus 2 lambda t. Therefore we get probability of x of t equal to 1 to be 1 by 2 times 1 plus e power minus 2 lambda t. Now expected value of x of t is xi in sigma xi into p of xi. So minus 1 times p of x equal to minus 1 plus 1 times p of x equal to 1. So minus 1 times probability of x of t equal to minus 1, which is minus 1 times 1 by 2 e power 1 plus e power minus 2 lambda t plus 1 into 1 by 2 times 1 minus e power minus 2 lambda t. So simplifying, we get e minus e power minus 2 lambda t. So expected value of x of t is minus e power minus 2 lambda t. Now the autocorrelation of rx of t1 t2 is equal to expected value of x of t1 times x of t2. So x of t1 times x of t2 can be taken as a new random variable which has two possible values, 1 and minus 1. So it is 1 if x of t1 and x of t2 equal to 1, the product is 1, and which is minus 1 if product of x of t1 times x of t2 is minus 1. Therefore expected value of x of t1 times x of t2 can be taken as 1 times probability of x of t1 and x of t2 equal to 1 and minus 1 times probability of x of t1 times x of t2 equal to minus 1. So within the duration of t1 to t2, if x takes a value of 1, that is the probability of x of t1 times x of t2 equal to 1. And similarly within the time t1 to t2, if the number is even, then x of t1 and x of t2 equal to minus 1. Therefore substituting, instead of t we put t2 minus t1 in the Poisson expression, and then we get 1 by 2 times 1 plus e power minus 2 lambda times t2 minus t1 minus 1 by 2 times 1 minus e power minus 2 lambda times t2 minus t1. Simplifying, we get e power minus 2 lambda times t2 minus t1. So this is the case. So we get the autocorrelation t1 t2 equal to 1 e power minus 2 lambda times t2 minus t1 for t2 greater than t1. Now we are asked whether x of t is Whiteson stationary or not. So for random process Whiteson stationary if the mean is constant with time and the autocorrelation only depends on tau, which is t2 minus t1. So the autocorrelation here only depends on tau for tau equal to t2 minus t1 for t2 greater than t1. However, the mean is not constant with time. We have a t term in the mean, so expected value of x of t was minus e power minus 2 lambda t. Therefore, the mean is not constant. So x of t is not a Whiteson stationary process.